All right, hello everybody. I wanted to talk in this video just about the number of solutions in a little bit more detail, and I want to approach it from a couple different angles. We're talking about quadratic equations, and there are a couple different situations you can get into where you have a different number of solutions to the problem. So the simplest example that I want to start with is just looking at three related equations: x squared equals 4, x squared equals 0, and x squared equals negative 4. In all of these equations, I can solve just by taking the square root of both sides. But I get different things depending on what number I'm square rooting. In the first problem, I get x equals positive 2, because 2 times itself is 4. And I get x equals negative 2, because negative 2 times itself is also 4. So this one has two real solutions. In the second one, I get x equals 0, because 0 times itself is 0. I could write down x equals negative 0, but that's redundant. That's the same number as what I just wrote down, so we really just say there's one solution. Sometimes people will say it's a repeated root, and I'll get back to what that means in a second, but for right now, I hope we agree there's just one number that solves it, just one real number. In the third one, I can't say that x equals 2, because 2 times itself equals 4. So we make up a new number called 2i, and 2i times itself makes negative 4. Similarly, negative 2i times itself would also make negative 4. The negative 2 times negative 2 makes positive 4, and the I times itself makes negative 1. So together, a negative 2i times itself makes negative 4. So we have two ways of describing this: no real solutions, or equivalently, two complex solutions. I could also use the word imaginary here. When I look at these three different situations, I like to think of them graphically. The first one is asking about when does y equals x squared intersect with y equals 4? It intersects with it twice. The second one is when does y equals x squared intersect with y equals 0? Y equals 0 is the x-axis, so I'll use a different color. You can see that these two graphs intersect once. And the last one, when does y equals x squared intersect with y equals negative 4? They don't. You have to imagine that they do. They don't really intersect. You have to imagine that they do. So this can show up in a simple example like this. It can also show up in more complicated examples, like, for example, if you're trying to solve with the quadratic formula. So let's look at two examples here. Something like negative 2x squared plus 3x plus 13 equals 0. I know what kind of situation that will be. Or negative 2x squared plus 3x minus 31 equals 0. So let's run through the quadratic formula. I'll do it on both of these problems. I'm going to use the same formula. I'll just write it here in the middle. Negative b plus or minus square root b squared minus 4ac over 2a. For the one on top, I'm going to have negative 3 plus or minus square root 3 squared minus 4ac all over 2a. So I'm taking the a, b, and c. This is a, this is b, and this is c. I'm taking the a, b, and c, and then I'm going through and putting those numbers in. So I end up with negative 3 plus or minus 9. And then 4 times 2 times 13, I don't feel like doing that multiplication. So I'm just going to grab a calculator. 4 times 2 times 13 is 104. Because there were two negative numbers, I write positive 104. 2 times 2 is 4. I can tell right now that there's going to be two solutions. And the way I can tell is because the number underneath the square root is a positive number. Remember in the previous examples, when I took the square root of positive 4, I got two real solutions. Here, it's the same sort of idea. I'm just taking the square root of positive 113, which my calculator tells me is 10.63. So my two answers that I get are going to be negative 13.63 divided by 4, because that's negative 3 minus 10. Or if I do it the other way, if I add it, then I could get 7.63 over 4. So whatever those come out to be, the point isn't so much what the numbers are, but that there are two real solutions. So what I'm going to do now is go to the second example, and I'm just going to overwrite what changes, because all I did was I changed c from 13 to negative 31. So this value right here isn't 13 anymore, it's just negative 31. This value right here isn't 104 anymore. I go 4 times 2 times 31. And because there's three negatives, negative 4 times negative 2 times negative 31, I get minus 248. Instead of this being 113, 9 minus 248 is negative 239. And I know right now that there are no real solutions, because I know that the square root of a negative number is not a real number. So what I can tell you is that the first graph here touches the x-axis twice, whereas the second graph does not touch the x-axis at all. In general, the idea is talking about this stuff underneath the square root. It's called the discriminant, which you don't need to know that, but it is called the discriminant. It's this idea that if you just calculate b squared minus 4ac, there's three options. Option 1, it's positive. If it's positive, then guess what? You've got two real solutions. Option 2 is it's negative. That's like in the purple example I just did. If it's negative, then you have no real solutions, which is equivalent to saying two complex solutions. And number 3, it's 0. And if the discriminant is 0, that means you have one solution, one real solution. One caveat is that if you're going to be using the quadratic formula, you got to make sure that your problem equals 0. So on my original examples where I had something like x squared equals 4, I would need to rewrite that as x squared minus 4 equals 0. And if I did my b squared minus 4ac, I'd be doing 0 squared minus 4 times 1 times negative 4, which is 0 plus 16, which is positive. So that matches up with what I just said about the discriminant. So you don't need to know the fancy discriminant word. Really, if you try to solve a problem, you take the square root of a negative, no real solutions. Take the square root of 0, one solution. Take the square root of a positive, two real solutions. Please let me know if anything was confusing. Happy to help.